Good morning, my YouTube viewers. It's Crystal here. In this video, we're going to be discussing simulations and how you can create a simple simulation in R. So a person uses loops for simulations in R when they need to repeat a process many times, track the results, and study how randomness behaves across iterations. Loops enable the researcher to build a world, run it thousands of times, and watch what emerges. A simulation is when the researcher completes a random act, records the outcome, and repeats the process many times. And loop is a natural way to express that repetition. So a loop is something that appears in pretty much every programming language that I've ever learned. And so what we're going to do is we're going to create a simulation with a for loop. Excuse me, I've had a 3-week cold now. So results is your variable, becomes it's a numeric of 10,000, a length of 10,000. So it's a numeric value with a length of 10,000. And then we're going to create a for loop for I in 1 to 10,000. And then sample mean equals mean brackets sample 1 to 6, comma 30, comma replace equals true. So you're going to sample a value of 1 to 6 30 times, and then you are going to replace it. And then so results I becomes sample mean. And then so sample mean is going to be a variable where all of the results of the sample are stored. And then so, and then we're going to create a histogram of this sample. So you can see this is the histogram that we have created where it has a number of 1 to 6. Actually, it says the lower limit is 2.5 and the upper limit is 4.5. But if you look at the graph at the x-axis, it is 0 to 6 or 1 to 6. And then so you can see the frequency is going to be 0 to 2,500. And then so the maximum number of times that you're going to sample this and get the mean of it is going to be 10,000. And so the highest mean is going to be about 3.5, and the lowest mean is going to be, 1 to 2.5 and 4.5 to 6, which is interesting because if you watched a recent video that I made, I was talking about dice rolls, and the dice rolls said that the average roll of dice is going to be, of a 6-sided die, is going to be 3.5. And then so basically we created a simulation where you rolled the dice and maybe 1,000 times, 100 times. And then as you increase the number of rolls of the dice, the average roll of the dice was 3.5, which turned out to be true. It turned out to be true that the average roll of the dice was 3.5 because we proved it. And this histogram here also proves something called a central limit theorem. And the central limit theorem states that it doesn't matter what the distribution is. If you sample the distribution enough and take the mean of the samples, then the means of the samples is going to approach a normal distribution. And that's exactly what we've proven here. In this example, it proves the central limit theorem, although we were just creating a simulation just to show you how to create a simulation using a for loop. So we've actually proven 2 principles in this one simple little for loop. So the next way that you can create a simulation is using replicate, R has a replicate function, so you can use the replicate function without having to actually use a for loop. I mean, you can use the for loop, and people who are new to R may decide to use a for loop, but when they learn more of R's commands, then they might want to use replicate. So R's replicate functions is one of the cleanest, most elegant ways to run simulations without writing explicit loops. So we're going to write a small little program to use the replicate function to create a simulation. So set.seed as 1, 2, 3. So what that means is we're going to set the seed, so every time you run this cell, it's going to initialize the variables to the same values. So results becomes replicate 10,000, because you know in our previous example or previous simulation we used a for loop, and that simulation was 10,000 as well. So you're going to have number of simulations is going to be 10,000, and the mean brackets are norm. So you're going to take your randomly sample a normal distribution, and so it's going to be of 30, 50, 10, and so that's going to be your mean. So you're going to randomly sample, and it's going to be pretty, same as this one. Of mean is 1 to 6, 30. You're going to take 30 samples, and it's going to be a sample with replacement. And so this is going to be mean brackets are norm. So that's a normal distribution. You're going to sample it 30 times. And I think the mean is going to be 50, and the standard deviation is going to be 10. But you're going to repeat it. And then you're going to expect the results. So you're going to have your mean of your results, and you're going to have a standard deviation of the results. And then you're going to create histogram of the results. So hist brackets results, comma, breaks equals 40, color equals sky blue. So your mean is going to be 50, and your standard deviation is going to be 1.8. And you can see that is what we set it up. We set it up with a mean of 50 and a standard deviation of 10. At one point, I think it said the variance was 10, but it's definitely 10. And so your mean is 50 and your standard deviation is 1.8. So it did actually get the mean correct. So we're going to create a histogram of the results. And so basically we started with a randomly sampled normal distribution, and the distribution that the samples has created also resembles a normal distribution. So that proves the central limit theorem. So your frequency is going to be 0 to 1,000, and your the range is going to be basically 45 to 55 with a mean of 50. And so the more times that you sample this normal distribution, the closer the distribution that the means makes is going to resemble a normal distribution. So again, that proves your simple central limit theorem. So in this video, I've showed you 2 ways that you can create a simulation in R. The first being the loop. I think most people learn how to create loops when they study programming. And then the second way is the replicate function. And so you can use whatever method is easiest for you, best for you to use. So that concludes this video. The next video we're going to be talking about some other statistical topics. So I hope that you decide to watch it.